Good afternoon, students. Welcome to the chemistry session. So, what have we learned till now? Till now, we have learned about pure substances and how they are classified, and we have learned the properties of each subclassifications. That is, pure substance is classified into elements and compounds, and elements are further classified into metals, non-metals and metalloids. We have learnt each type or each subdivision very carefully, including the properties. Now, coming to the mixtures, I have already introduced you to the word mixture, which is otherwise called as impure substance. So, what is a mixture? I have told you, and today we are going to learn more about mixtures and their types. A kind of or a type of different types of mixtures also I have introduced based on the state in which the combining substances are. But then now I had that time also I had told you that based on their properties we have two particular types of mixtures which we are going to learn today. Okay, welcome to the session, students. So, let me give you information about mixture. Let's recall what do we mean by mixtures. So, in the screen you can see that sulfur powder is kept, iron filings are kept. These two are elements. So, it comes under pure substances. So, when they are mixed with each other, you get a mixture of sulfur powder and iron filings. So, how do we define mixtures here? Mixtures are substances that are substances that are made up of two or more pure substances. So, when two or more elements or compounds or a combination of both is together physically in any ratio, but they are not chemically combined, then it is called as a mixture. You take some sulfur, a spoon of sulfur and 3-4 nails, then also it is a mixture. You take a lot of iron nails like 6 and 7 and very little, a pinch of sulfur powder, then also it is called as a mixture. So, here the composition is variable. It need not be a fixed proportion of combining. So, the first property of mixture I just told you is composition. You can see in the picture that there are two substances, salt and sand. Salt is at white color and sand is at yellow color. So, you can see in all the three watch glasses there are different composition, that is salt is more in the first plate, in the second plate sand is more, in the third plate both are almost equal, looking equal. So, it can be in any proportion, still it is called as a mixture. So, now second property is that constituents are separable, that is we can separate the components of a mixture using any physical method. That physical method we want to opt for, or we have to opt in order to get the constituents, is based on the property they have. For example, here iron is magnetic, therefore using a magnet we can easily separate iron nails from the sulfur powder mixture, right? Yes. So, third property is that no new substance is formed when you mix. So, when you mixed iron and sulfur powder, we didn't get ferric chloride, iron chloride or something, that is what it means. So, they remain separated. Then during the process, that is when we are mixing two pure substances, like when we mix sulfur powder and iron nail, there is no heat generated. So, none of the energy, there is no heat generated, neither we have to provide it heat in order to form a mixture. We just have to mix it with a spatula or a stirrer or something. So, mixture is done, right. So, we need not heat it, or the heat is not even produced during the reaction. So, energy is neither given out nor absorbed. And the fourth property is that you know that when we take a pure substance like water, which is a compound which comes under pure substance, pure water, distilled water, the boiling point is 100 degrees Celsius. Sure, because from the first chapter we have learned that boiling point of distilled water is 100 degrees Celsius. In Kelvin it is 373 Kelvin. But if it is a sugar solution, that is a mixture and no more a pure substance, then water is there, but still the boiling point will vary depending on how much of sugar you have dissolved in water. So, since the composition is also variable in mixture, boiling point cannot so be not fixed. So, we can say that mixture does not have a sharp melting or boiling point. Now, you can see 3 beakers. Okay, in these 3 beakers, if you can see in these 3 beakers, the first sample we have salt water, second sample we have chalk powder dissolved in water trying mixed with water, the third sample we have milk. So, a beam of light is passed through all 3 solutions through a torch. Using a torch, a beam of light has been passed through all the 3 solutions. What do you observe? You can observe that you cannot see the beam of light in salt water, isn't it? It is not illuminating the solution, whereas in chalk powder and water it is showing the beam of light is seen and is also broadened because the particles in the chalk powder are large enough, therefore they can scatter the beam of light. Once the narrow beam of light comes or passes through particles, little larger particle than that of salt, then it scatters the beam of light and broadens the beam of light. You can see that the beam of light has been broadened from a narrow beam, it has broadened, and when you see when it is passed through a milk solution, then it's actually more, it has become more wider. So, in general you can say that based on this experiment you can say that even mixtures can be of different types. So, here all the 3 are mixtures. One is mixture of salt and water, another is mixture of chalk powder and water, another one is milk, which is also a mixture of water, carbohydrate, protein, and many vitamins and minerals. Still they are showing different properties. So, based on the difference in properties of these mixtures, we have types of mixtures, that is homogeneous and heterogeneous mixtures. Now, homogeneous and heterogeneous mixtures I would go further with. So, what do we mean by homogeneous? This is the actual types. So, types of mixtures based on the physical states, I have already told you that it may be a solid mixture like alloy, solid liquid mixture like salt water or sugar solution. It can be liquid like alcohol and water, alcohol solution. It can be gas and liquid like carbonated drinks or aerated drinks. It can be gas and gas like air. So, there are different types based on the physical state of the combining components or the mixture in the components in the mixture, but based on the property the solutions show, mixtures show, we have 2 major types. First one is heterogeneous, second one is homogeneous. As the word says, we will start with homogeneous. It is simple. Homo means similar composition or uniform composition. Genus means generating. So, if a mixture is generating a uniform composition, then the mixture is called as a homogeneous mixture. For example, you can see this salt solution. When you dissolve salt in water, can you see the salt particles in the solution? No. It looks like plain water itself, isn't it? It does not show that variable composition. And if we try to just sip a little salt water from different corners of the beaker, does it taste differently? No, not at all. It tastes the same. That means that every part of the solution has same amount of salt and same amount of water. This is what is meant by homogeneous. So, in general we can just define homogeneous mixture as a mixture in which various constituents are mixed uniformly. Okay. Now, other than salt solution, we have some more examples like brass, wherein it is a mixture of zinc and copper. Already I have told you. See, throughout the instrument, it has same percentage of copper, same percentage of zinc, not same percentage of copper and same percentage of zinc. That is, zinc is 70% and 30% is copper throughout. In salt solution, if I have added 10 grams of salt in 100 ml of water, so what will be the composition per ml? So, for 100 ml it was 10 grams. So, per ml it will be 0.01 gram. So, it will be 0.01 gram of salt in all the corner of the solution. So, in alcohol also the amount of alcohol and water will be same in all the corners of the solution. There is no gradation or difference in the composition. Now, going to heterogeneous mixtures. So, while discussing about mixture, we took the example of this, that is iron nails and sulfur. So, here when we mix iron nail and sulfur, you can easily see that some places there are no iron, some area of the container there is no iron nail, only sulfur powder, isn't it? That means it has not been distributed uniformly. So, this is an example of heterogeneous. Hetero, it is different composition, non-uniform composition. Genus, generating. If a mixture is generating a non-uniform composition, then such mixtures are called as heterogeneous mixtures. Hope you are clear with what do we mean by heterogeneous and homogeneous mixtures. Now, let us list out the differences. So, here we have the differences between homogeneous and heterogeneous mixtures. Okay. Okay. Now, homogeneous mixtures have these properties. So, it is a mixture which has uniform composition. The particles of the mixture are not visible to the naked eye. Like for example, in salt water or alcohol water, can you see the alcohol or the salt? No, salt particles not at all. So, they are the particles in the mixtures are not visible to the naked eye. The particles cannot be separated by filtration. We have discussed salt water you cannot separate by filtration. You have to evaporate, isn't it? Okay, or heat. The particles, the mixture is stable. They, after allowing it to stand for some time, salt does not settle down. It remains in the solution itself, isn't it? Therefore, it is said to be stable. They do not settle. So, you saw in the first example that the path of beam of light is not visible in case of salt solutions. So, in homogeneous mixture, they do not scatter light because of the size of the particle. The size of the particle in homogeneous solution is very, very small. It is said to be less than 1 nanometer. And more about homogeneous solutions, which is otherwise called as true solution, I will be taking up in the next session. Since the particles are very less, they do not have the ability to scatter the beam of light. Since they cannot scatter the beam of light, the solution is not illuminated. You cannot you cannot see the solution light inside the solution, right? If you don't remember, I will show you again. So, this was the slide I am talking about. Yes, you can see that in this salt water you cannot see the light passing through it, isn't it? It is not passing through this solution. You cannot see the beam of light passing through the salt solution. So, since this is an example of homogeneous solution, so this becomes one of the property of homogeneous mixtures. Now, in for examples, you know examples of homogeneous solution: sugar solution, salt solution, copper sulphate solution, pure copper sulphate solution. Many examples you can tell about. So, usually that passing the beam of light is true only if it is a liquid aqueous solution. Okay. So, do not ask me whether if we just dissolve, like for example, brass was an example of homogeneous mixture. So, what happens when you pass light through it? You know that it is opaque, thick, so light cannot pass through it. Okay. Coming to heterogeneous mixtures, these are the mixtures which have a non-uniform composition. I have mentioned, I have told you the meaning of heterogeneous, right? Non-uniform composition which generates mixture which generates a non-uniform composition. Here the particles are visible to naked eyes. See, the other two solutions, for example, it was chalk powder and water and also milk. Milk, actually you cannot see the particles, but okay, some of the examples like muddy water or carbonated aerated water and all, you can see that, you can see the, no, you can only, will take sand water, mud water, we can take chalk powder and water. In these solutions we can see the particles through your naked eye. You can see the chalk powder through your naked eye, right? Okay. Usually in heterogeneous mixtures the particles can be seen through our naked eyes. Like even in milk, if you take 1 glass of water, after you add a spoon of milk or 2 to 3 spoons of milk, you can make out the particles, right? You can see it is moving, or the white color liquid is moving through your glass of water and the solution has become turbid. So, this shows that the particles are seen. We can see it through our naked eye. Okay. So, it changes the color, it becomes a little different, and it may not be homogeneous. It looks homogeneous, but it is not homogeneous. So, you can say that heterogeneous mixtures are mixtures wherein particles can be seen through our naked eye. The mixture is unstable, that is they settle down. Chalk powder, if you mix and wait for some time, it settles down. Chalk powder settles down. So, you can say heterogeneous mixtures are unstable. The particles can be separated, isn't it, by filtration. That is chalk powder mixture, you can try making it, or sand water, I have told you. Filter it, you can see the filtrate has water in it and the residue will contain your chalk, or even it's tea is an example. Tea leaves can be separated from tea by using a strainer. So, thereby you can say that the residue, you have separated the tea leaves from the tea. Okay. Now, another property is that here, since the particle size is more than 1 nanometer, you can see, I had told you that the particles can be seen in a heterogeneous mixture. So, they have the ability to scatter the beam of light and make the path of light visible to you. Remember, just few when I was explaining homogeneous mixture, I showed you. So, the beam of light was, the band of light has increased its width and you can see the beam of light where it is moving. The path of light is visible through two samples. Which were the two samples? Chalk powder and water and milk, right? Through that, when a beam of light was passed, you could see. So, those two are the examples for heterogeneous mixtures. So, these are the different types of mixtures and the properties of of mixtures. So, in this session we have completed with what do we mean by mixtures and the properties and the two different types of mixtures with their properties and examples. So, in the next session we will continue with the types of homogeneous and heterogeneous mixtures, the sub classification. Till then, take care, be safe, have a nice day. Bye.